Welcome to SSR Pharma Media, your trusted source for pharma knowledge. PIC MCQ series, your exam power boost. So today we are going to discuss about Pharmaceutical Inorganic Chemistry Limit Test Part 2. Prepare, practice, succeed. So in limit test, already we have discussed about limit test introduction, limit test for chloride, limit test for sulfate, limit test for iron, limit test for heavy metal, limit test for lead in part 1. In previous video, we have discussed. Today, we are going to discuss part 2. So, limit test for arsenic, modified limit test for chloride and sulfate. So, let's discuss about limit test for arsenic, principle and apparatus, medium, observation and report. So, first is the principle. So, in limit test for arsenic, reduction of arsenic compound to arsine gas, which reacts with mercury chloride paper to form yellow stain. And apparatus used in the limit test for arsenic is Gutsit apparatus. It's a glass generated with delivery tube and mercury chloride paper it's contained. And in the medium, HCl is used as a medium. And in observations, yellow or brown stain on mercury chloride paper. Compared the intensity of color with the standard with test. And report, the test passes if the intensity of color yellow stain is not darker than standard arsenic stain. So this is the apparatus of Gutsit. So in the Gutsit apparatus, so you take the snapshot and you study all the parts. So it's a glass jar containing reagents. All reagents we will take in this bottle, and this is the tube. Through this tube, the arsenic gas will enter. Here mercury chloride is present. So it enter and reach the mercury chloride paper. So we'll discuss about the reactions. So arsenic present in the sample, when we are adding stannous chloride and HCl medium, it reduced into arsenic acid. So stannous chloride and HCl act as a reducing agent. Then this arsenic acid, in the presence of potassium iodide and HCl, it reduced into arsenious acid. So after that, so in the meanwhile, the zinc we will take in this glass jar. The zinc and HCl medium both are reacted to form nascent hydrogen. So this nascent hydrogen, it's a H2. So nascent hydrogen react with arsenious acid to form arsine gas. So this arsine gas is formed over here. So after forming the arsine gas, so it traveled through this tube and it reached the mercury chloride paper. So mercury chloride paper is present between this rubber band. So here mercury chloride paper, and it reached the mercury chloride paper and it formed arsenic mercury complex, which is yellow brown in color. So this color intensity is compared later in order to find out the report. So while doing the test, so in this tube, the arsenic gas travel through this tube. So between this tube, lead acetate cotton plug is kept. So the reason for using lead acetate cotton plug is, so during this reactions, sometimes the sulfur dioxide and sulfur impurities may form. So that impurities may damage when travel through this tube, and when reaching this mercury chloride paper, it may damage that paper. So once if it is damaged, very difficult to compare the color intensity inaccurate. So in order to prevent the impurities of other gases, we have kept lead acetate cotton. So limit test, the purpose of reagent used in this limit test for arsenic, zinc. So zinc react with hydrochloric acid to liberate nascent hydrogen, which reduces arsenic compound to arsine gas. And hydrochloric acid is a medium, provide acidic environments required for nascent hydrogen generation from zinc and dissolves arsenic salts. Also ensures the smooth and reduction to arsenic gas. And potassium iodide is act as a mild reducing agent and ensuring complete reduction of higher oxidation state of arsenic, thereby facilitating arsenic formation. And stannous chloride is enhanced reduction of arsenic and prevent interferences from other metals by maintaining arsenic in the trivalent or pentavalent oxidation state before reduction to arsenic. Lead acetate carton, which absorb the sulfide, hydrogen sulfide and other interfering gases formed during reactions, and protecting mercury chloride paper from discoloration not due to arsenic. And mercury chloride paper detect arsenic gas by forming yellow brown arsenic mercury compound, and the stain intensity corresponding to the arsenic content. And in acidic medium of HCl, it ensures the nascent hydrogen generation for reductions and prevents precipitation of arsenic as insoluble hydroxides or oxides. So limit test for arsenic key points. You note down the key points. It's a very important in order to remember this arsenic principle. Take a snapshot and read it. So we'll move into the questions. Which apparatus is especially designed for arsenic limit test? So the answer is option C, Gutsit apparatus. So Gutsit apparatus allows controlled generation of arsenic gas and direct it to react with mercury chloride paper safely. The principle of the limit test for arsenic is based on, so the answer is option B, reduction of arsenic to arsenic gas and its reaction with mercury chloride paper. So arsenic present in the sample is reduced to arsenic gas, which reacts with mercury chloride paper to form yellow to brown stain, the intensity of which indicates the arsenic content. So what is the chemical formula of arsenic gas? So the answer is option C, ASH3. So ASH3 is a volatile, that means arsenic gas is a volatile and toxic hydride of arsenic produced during the limit test reaction. In the arsenic limit test, arsenic is reduced from which oxidation state? So the answer is option C, +5 to -3. So arsenic in a compounds like arsenate, CaS53 plus is reduced to arsenic gas ASH3 as in -3 oxidation state. Which reagent acts as the reducing agent in the limit test for arsenic? So option B is the answer, zinc and hydrochloric acid. So zinc react with hydrochloric acid to liberate hydrogen, which reduces arsenic compound to arsenic gas. It's a nascent hydrogen. What is the role of zinc in the arsenic limit test? So the answer is option C, reducing agent to generate nascent hydrogen. Which reagent absorbs and reacts with arsenic gas in the test? So answer is option A, mercury chloride paper. So mercury chloride paper absorbs arsenic gas, producing yellow to brown stain of arsenic mercury chloride compound. What is the color change observed on mercury chloride paper if arsenic is present? So the answer is option C, white to yellow. White to yellow or brown to yellow. Arsenic, so white to yellow is the answer, correct answer. Arsenic gas reacts with mercury chloride paper forming yellow to brown stain. Yellow or brown stain due to the formation of arsenic mercury complex. Which acid is commonly used in the arsenic test? So option A, hydrochloric acid. So hydrochloric acid acidifies the medium and reacts with zinc to liberate nascent hydrogen for arsenic reduction. The purpose of adding potassium iodide and stannous chloride is, so option B, to prevent interference and stabilize reduction. So potassium iodide and stannous chloride enhance the reduction of arsenic and helps eliminate interference from other metal ions. The reaction between arsine gas and mercury chloride vapor produces, so option A, Ag2As2, means arsine react with mercury chloride to form yellow to brown arsenic mercury compound, so complex. So that complex is Ag2As2 structure. Why is the glass wool plug used in the gutsit apparatus? So the answer is option B, to absorb hydrogen sulfide and protecting mercury chloride vapor. Otherwise, so other gases, these gases may damage the mercury chloride vapor. Arsenic standard solution for limit test ppm. So option A, 10 ppm of arsenic standard solution is used. Next we will see about the modified limit test for chlorides and sulfates. Why modified limit tests are needed? Certain substances cannot be tested directly using standard limit test procedure given in pharmacopoeia like IP, BP, USP because they interfere with the test reaction. Hence, the procedure must be modified or altered before applying the limit test for chlorides and sulfates. So now we are going to discuss about these three limit tests. Modified limit test for chloride sulfate, the sample of potassium permanganate, and modified limit test for chlorides and sulfates in sample of sodium benzoate. Modified limit test for chlorides and sulfate in sodium salicylate. So potassium permanganate in modified limit test for chlorides and sulfate. So deep purple color, the problem in the direct test means the deep purple color of potassium permanganate masks the turbidity produced in chlorides and sulfate test. So you all know potassium permanganate is a dark violet or pink color. So due to the presence of the color, we cannot identify the report whether it's a opalescence or turbidity presence or not. So such compounds will take into the modified limit test. So due to the reason for modification, the sample color interfere with the visual comparisons. So modification done means we have to do for the pre-treatment with alcohol. When we are doing pre-treatment with alcohol, potassium permanganate reduced into manganese dioxide. It is a brown precipitate, and after forming the brown precipitate, we filter and will remove the precipitate and we take the colorless filtrate for the testing. So this is the modified limit test for chloride and sulfate by altering the procedure. Next, for sodium benzoate. So sodium benzoate is a benzoate ion, is organic matter. So interferes and may contain chlorinated impurities due to benzoic acid is being a manufacturing of or chlorinated derivative of toluene. So due to the manufacturing problem, the chloride may present as an impurity in this sodium benzoate sample. So in order to detect the chloride impurities, so we will take the sample into the reason for modifications. Modified limit test we are taking. The reason, the organic part must be destroyed so that the chlorine convert to sodium chloride which can be tested. So modification, heat with sodium bicarbonate, then char below 400 degree Celsius to extract with the water, and dilute nitric acid is added and it forms the precipitate of benzoate and filtered, and precipitate is removed and filtrate is used for the limit test for chloride. Next is sodium salicylate. So the organic compound forms complex and interferes with the chloride and sulfate reductions. So that means when we are limit test for chloride and sulfate, we are using the mineral acid. So that mineral acid may react with the sodium salicylate and it form the salicylic acid. It is the insoluble precipitate. So that precipitate may interfere with the observation of turbidity and opalescence. So that we should modify this procedure. So need to decompose organic matrix and remove the salicylic acid. So the how to do modification means add dilute nitric acid or HCl, hydrochloric acid, and decomposes of salicylate to salicylic acid. So all sodium salicylate converted into salicylic acid. Sodium salicylate is a water soluble, salicylic acid is a water insoluble precipitate. So that precipitate is removed, filtered and removed, and we will take the filtrate for the test for chlorides and sulfates. So question, in the modified limit test for chlorides and sulfates, in potassium permanganate, alcohol is added to. So answer is option B. Reduce potassium permanganate to manganese dioxide and remove its color. Next, which of the following product is formed when KMnO4 reacts with ethanol during pre-treatment? So the answer is option C, acetaldehyde. So KMnO4 react, potassium permanganate react with alcohol to form manganese dioxide. It's a brown color precipitate. So after that it forms acetaldehyde and potassium hydroxide and water. So oxidize to acetaldehyde. Why is the filtrate obtained after treating KMnO4 with alcohol suitable for limit test? So option C, it becomes colorless after removal of MnO2, manganese dioxide ions. Next, chloride impurities in sodium benzoate arise mainly due to, option B is the answer, manufacturing of benzoic acid from chlorinated toluene derivative. So that the chlorine may enter as impurity into the benzoic acid. So we want to test whether chlorine is present or absent by using modified limit test for chlorides and sulfate. In the modified limit test for chlorides in sodium benzoate, heating below 400 degrees Celsius ensures, so option B, complete destruction of organic matter without volatilizing sodium chloride. The residue after heating sodium benzoate is extracted with, so option C, water and dilute nitric acid. The solution of sodium salicylate is prepared using, option A, carbon dioxide free water. During the chloride limit test for sodium salicylate, nitric acid is added to, option B, decomposes sodium salicylate and liberate salicylic acid. The limit test used in pharmaceutical analysis is an example of which type of analytical method? So answer in the comment box. So join in our WhatsApp community. You will get hands-on material and number of test series to check your knowledge. So thank you. Like, subscribe and share. Thank you.